Hi everyone, I'm Vikram from Mathematics City. Welcome back to another video. Now in the last video we learned how to solve an OR inequality. This video we're going to be learning how to solve an AND inequality. Now they're quite similar except for one major difference. In an OR inequality, only one of the constraints has to be met. In an AND inequality, both the constraints will be met. Now there's two different ways of writing compound inequality or compound AND inequality. This is one of the ways. I'll go over another way to write down the same exact thing after we solve this. So how do we solve this? We have to solve this first and then this. So let's solve this first inequality. We know how to solve this. This is just a simple two-step inequality, right? So the first thing we have to do, let me erase those lines. So I'll show our work over here. So, first thing we have to do is minus 4 on both sides. So, actually, no, I'll just do the work here. Minus 4, and then minus 4, not too much space right because of that big fat and over there. But anyways, now the plus 4 minus 4 get canceled out. Negative 4x on this side is greater than 36 minus 4 is 32. Divide both sides by negative 4. We have to switch the sign. So now we get x is less than negative 8. So let's write down. So the solution here is x is less than negative 8. And we all know how to graph that, hopefully, because we learned how to graph an inequality, I think, 2 episodes ago. So x is less than negative 8. Now let's look at this one. This is a one-step one. It's super simple. Just divide both sides by 3. We learned how to solve a one-step inequality long time back. Let's take a trip down memory lane and do one-step inequality. So we're just left with x on this side because the coefficients get canceled out. And then greater than, we don't need to switch the sign this time because the coefficient's not negative. Negative 42 divided by 3 is negative 14. So x is less than negative 8 and it's greater than 14. So x is less than negative 8 and greater than negative 14. So now we know the constraints that have to be met, right? So it can be anywhere. It can be anywhere from negative 14 to negative 8. It can be anywhere in that range. So if we graph it, I think we'll graph it. It's not the best looking number line, but it's good enough. So we can put negative 14 on the side because it's the smaller value of the two values, and then negative 8 over here. And when we draw that line, the circles will stay open. Oh, that looks like a closed circle. Circles will stay open because it's not greater than or equal to or less than or equal to. We are not including negative 14 and negative 8. They are just the two endpoints, I guess, of that line segment we're drawing there. And another way to draw this, so x is less than negative 8, so x is less than negative 8, we can write that down. So this is another way to write an AND inequality. So x is less than negative 8, and it's also greater than negative 14, right? So we can put this less than sign for x and then 14 over here. So 14 is greater than x and less than negative 8. That's how we would write that down. So two ways of writing down an AND inequality, we can also graph an AND inequality as well. So, and as you can see, we don't need to draw like a ray, we have to draw a line segment because there's two constraints, not one constraint, because it's an AND inequality. So thanks for watching this video. Stay tuned for the next videos in our series. Make sure to check our website, link in the description. Have an awesome day wherever you are in the world. Keep calm and love math. I will see you later. Bye.